Okay, so in this video, we're going to talk about symbol that we find in our periodic table. We also want to talk about families and periods. Okay, so if I look oxygen, if I grab oxygen and place it in here, and I will see some important stuff related with oxygen. So first of all, oxygen has the symbol O, and here in my periodic table I will see a number. This number is called the atomic number. This number tells us how many protons we have for that specific atom. Each one of these elements here has a specific atomic number, and we follow the order in our periodic table. So I know that this is 8, oxygen has 8 protons. So nitrogen has 7, carbon has 6, boron has 5, 3, 2, 5, 4, 3, 2, and 1. Okay, so the atomic number basically tells us how many protons the element has. In this other side here, I have for oxygen a 15.9994. What is that? That one is the atomic mass. The atomic mass or atomic weight, it is calculated by using the relative abundance of the isotopes. So we have, we want to do this calculation in this video, but this comes from how many different types of oxygen I have. So I do some calculations. The percentile I found then on Earth, and I run that calculation and ended up with that specific number there. On here, on the bottom, we have the oxygen number name. As we know, each one of these elements has their specific name, and it is located in the bottom part of your each element periodic table, in a periodic table. So hydrogen, lithium, sodium, potassium, and so on and so forth. Also, I want to talk a little bit about periods and roles. So our periodic table first started being organized for a scientist called Mendeleev. So he tried to organize our periodic table in columns, and the columns stands for elements that have the same chemical and physical properties, as well as in rows. And the rows stands for elements that has the same number of orbitals. So I know that in this row here, every single one of these elements has the same number of orbitals. I know that in this specific column here, each one of these elements has a chemical and physical properties, similar chemical and physical properties. Is it important to know that? Yes, it is. Why? Because once I know that this guy is organized with similar physical and chemical properties, when they combine with guys from this side here making ionic compounds, they will have kind of similar way to connect. Let me give you one example of that to clarify what I mean. Oxygen, I know that it has a 2- charge, and lithium, I know that it has a plus charge. So every time I make an ionic compound using lithium and oxygen, I need 2 of this and 1 of oxygen. The same thing would be applied for potassium. The same thing would be applied for sodium, for hydrogen, and so on and so forth. Why is it important to know that the element, the same role, has the same number of orbitals? Because knowing that, we can derive some ideas like electronegativity or ionization energy, or characteristics related with each one of the elements that is placed in that specific role. So just a review: atomic number tells me how many protons I have in my atom, in my element or atom. Atomic mass, and it's calculated by the average of my isotopes. And I have here columns, and this guys has similar physical and chemical properties. I have rows in my periodic table, and the rows tells me that these guys here, they have the same number of atomic orbitals.